Okay, so Assalamualaikum and hi everyone. In this video, I'm going to discuss about real gas and ideal gas. So the deviation from ideal gas law. Okay, real gas sisihan daripada hukum gas ideal gas equation. Alright, so apakah what is the assumption that we have already made in ideal gas? Okay, the first one, we have already assumed that the volume of the molecule is negligibly small compared to that of the container. So maksudnya di sini adalah isi padu, okay, isi padu molekul gas, zarah-zarah gas adalah terlalu kecil, okay, dan dia boleh diabaikan sekiranya kita, okay, so let's say this is our container and then this is the particle of the gas. So we can assume that the volume of this gas is very small, okay, sangat kecil berbanding dengan container of the gas. Alright, so kalau untuk attractive force, okay, and repulsive force between the gas molecules are negligible. So disebabkan dia terlalu kecil, kita boleh anggapkan attractive and repulsive forces between these gas molecules are negligible. Jadi ada dua, this is the first assumption yang kita buat untuk ideal gas. Okay, alright, di mana ideal gas equation dia adalah PV is equal to nRT. But sebenarnya ideal gas ini adalah assumption yang kita buat so that untuk memudahkan kita buat calculation. Tetapi in the real life, the gas is obey the van Waals equation. Okay, sebenarnya dia adalah real gases. Dan the difference dia yang pertama sekali kalau kita tengok dari segi from the ideal gas equation. So the ideal gas equation, ideal gas law is PV is equal to nRT, while for real gases is P plus N square A over V square times V minus NB and equal to nRT. Meaning that for P and V, okay, we include the correction factor. Okay, this is the correction factor for pressure, and then this is a correction factor for volume. Okay, kita include B dan juga A in the calculation. Alright, so yang kedua, the gas molecule are very small and they have a negligible volume. Okay, we can say that yang asal tadilah yang awal kita beritahu, okay, molekul gas sangat kecil dan boleh diabaikan. But actually in the real gas, the gas molecule has a certain volume, and the free volume where the molecules move about is smaller than the volume of the container. Okay, so maksudnya di sini ideal ni semua yang elok saja yang kita tengok. Sebenarnya in real, okay, dia mempunyai certain volume. Okay, right. Next, ideal gas mempunyai intermolecular forces. Okay, untuk intermolecular forces for ideal gas kita boleh abaikan. Okay, intermolecular forces between the molecules are negligible, and the collision between the gas molecule and the wall container exert a greater pressure. While for real gas, actually, there are weak attractive forces between the gas molecule, which reduce the frequency of collision between gas particles and the wall of the container. Subsequently, the gas exert a smaller pressure. Okay, kalau untuk real gas sebenarnya dia mempunyai pressure yang lebih kecil. Okay, that's why nampak di sini kita minus. For the pressure kita minus. Okay, N square A over V square. Alright, so next, okay, the effect of pressure and temperature on the behaviour of the real gas. Okay, kesan tekanan dan suhu terhadap sifat-sifat gas sahih. Right, so gas tend to behave ideally at higher temperature and low pressure. Okay, gas dia mempunyai kecenderungan untuk bersifat ideal pada suhu yang sangat tinggi dan tekanan yang rendah. Okay, pada at low pressure, what happen at low pressure? The gas molecule and the gas are far apart. Okay, the molecule of the gas are far apart. The attractive forces are negligible, and this makes the volume of the molecules is almost zero compared to the average intermolecular distance, and the gas will behave ideally. Okay, the volume of the molecules hampir kosong. Jadi dia menyebabkan intermolecular distance of the gas will behave ideally. So this is the graph that shows, okay, at a higher pressure, okay, kita boleh nampak di sini Bila pressure dia tinggi, so this one is a lower pressure. So at lower pressure, dia akan behave ideally. So this dotted line ini adalah untuk ideal gas. So plot the PV versus RT over RT, or PV versus pressure of the 1 mole of gas at 273 Kelvin, which is 0 degree Celsius. At higher temperature, well above the boiling point, pada suhu yang tinggi, okay, heating a gas increases the molecule average kinetic energy. Thus, the molecules then have the ability to overcome their mutual attraction. Bila kita panaskan molekul gas, okay, dia mempunyai average kinetic energy yang lebih tinggi. Okay, average kinetic energy tinggi. Because bila T is high, kinetic energy also increase. The molecule then have the ability to overcome their mutual attraction. Bila temperature dia tinggi, dia akan senang untuk mengatasi daya di antara satu sama lain. Alright, so this is for pressure. Okay, 1 mole at 203 Kelvin, okay, 293 Kelvin and 673 Kelvin, 1000 Kelvin. So you boleh nampak di sini, for this gas, okay, bila at 1000 Kelvin, dia semakin dekat dengan apa? Ideal gas. Okay, sebab apa? This one is higher temperature, this one is lower temperature. Okay, so bila low temperature, okay, low temperature dia menyebabkan deviation semakin jauh. Bila higher temperature, dia semakin dekat dengan apa ni? Garisan ideal gas. Okay, right. But remember, okay, two main factors for the deviation for real gas from ideality. The first one is volume of molecules. Second one is intermolecular forces. Okay, so dua ini adalah merupakan faktor yang sangat penting untuk deviation real gas daripada ideal gas. Alright, so Van Waals equation, okay, is the ideal gas equation need to be redesigned to describe the real gas behavior more accurately. Jadi kita akan gunakan ideal gas equation tadi untuk redesign dan membentuk Van Waals equation yang the one that I show you earlier. Okay, Van Waals just adjust ideal equation by correcting two parameters. Dia membetulkan dua parameter, iaitu parameter pressure, okay, kita minus, and then volume minus NB. So attractive forces between the gas molecule, and then number two, the volume of the gas molecules. Attractive forces between the molecules, dia merupakan forces that exist between the gas molecule will make the molecules move slower. Okay, molekul-molekul gas ini dia akan bergerak dengan lebih perlahan and decrease the collision between the molecules and the wall of the container. Jadi, the pressure exerted by the real gas is less compared to the ideal gas. Kenapa? Because dia menganggap ada daya tarikan di antara gas particles. Okay, jadi this gas particle, okay, untuk gas particle ini, okay, dia ada daya tarikan dan daya tolakan. Jadi bila ada daya tarikan dan tolakan, okay, bila dia kena dekat dinding kurang lah. Okay, alright. Since P real is less than P ideal, the term pressure need to be corrected by adding the coefficient n square A over V square. Okay, right. So this is the correcting factor untuk ideal dan juga real gas. Okay. Okay. And then note that n square A over V square dia merupakan correcting for molecular attraction, di mana A adalah constant that indicates the strength of the intermolecular attractive force between the gas molecules. While the greater the A, the stronger the attraction. And unit for A is atm liter square per mole square. While untuk volume for the gas molecule, untuk isi padu pula, in actual situation, okay, dalam keadaan yang sebenar, gas molecule occupy sizable portion container. Okay, alright. Dalam keadaan sebenarnya gas molecule dia mempunyai portion, sebahagian yang besar dalam container. The space occupied by the gas molecules have to be taken into consideration. Ruang yang diambil oleh molekul-molekul gas ini perlu diambil kira. And the space restrict the movement of the gas molecules. Jadi ruang ini dia akan menghadkan pergerakan molekul-molekul gas. And the volume occupied by the gas molecule must be subtract from the total volume. Jadi ini kita ada container, and then we have V effective. Ideal gas at low pressure and high temperature. Okay, real gas high pressure and low temperature. Okay, sebab apa? Bila low pressure, maksudnya bekas ni besar, jadi dia tiada daya tarikan. And then bila high pressure, okay, at higher pressure, dia tiada kinetic energy dia very high. Okay, untuk real gas high pressure, okay, bila high pressure nampak dia semakin rapat di sini, and low temperature, okay, dia akan menjadi efektif. Jadi ideal gas volume is negligible, no intermolecular forces. But for real gas volume is significant, intermolecular force is significant. Okay, thus P real less than P ideal. Okay, so V effective dia kita akan ambil kira untuk correcting factor NB. Thus V effective is V container minus NB. NB adalah occupied by the volume of gas. So correcting factor untuk volume adalah NB, di mana N adalah bilangan mole, B adalah constant that indicate the actual volume occupied by the gas molecules. Jadi semakin besar nilai B, the larger the molecules or the atom. And unit untuk B adalah liter per mole. Alright, so this is Van der Waals equation. Di mana Van der Waals equation, okay, as you can see from here, dia tambah apa? N square, N square over V square, dan volume dia minus NB. So Van der Waals constant for some common gases. Ini adalah constant Van der Waals bagi setengah gas. Kita ada gas A dengan gas B. Alright, so that's all for ideal gas equation. Thank you for watching.